Stripping down science. The Naked Scientists.
Hello, welcome to this week's Naked Scientists. It's our extravaganza of questions and answers this week. And it's with me, Chris Smith, with Dave Ansell. Hi, Dave.
Hi there.
And also with Helen Scales. Hi, Helen.
Hello.
Welcome. Now, on the way this week, why diet foods could actually make you fatter. Well, there's food for thought if ever I've heard of it. Also, the coral catastrophe that's happening in the Pacific, why reefs are being lost twice as fast as rainforests, it turns out. There's a massive meteor shower destined for Earth. It's coming tonight, and Dave will be telling you all about it. And a new way to fend off asteroids destined to hit the Earth. There's certainly a space theme to this week's show. It's a nuclear-powered drill, and I'll be telling you how that works in just a second.
Plus, we're trying to get to the bottom of this colourful kitchen science question from Neil in Coventry.
Recently I bought some matey bubble baths for my kids, and when you pour into the water it changes from red to blue. I was driving my wife up the wall trying to understand what was going on. Hopefully a naked scientist can answer this for me.
And we'll also be finding out why The Simpsons is a good way to learn more about science.
This perpetual motion machine she made today is a joke. It just keeps going faster and faster. Lisa, get in here. In this house, we obey the laws of thermodynamics.
And we do here in the studio too. This week is also our question and answer show. We will be answering any question you have for us. So you just need to call us or email us or send us a text message. And we'll also be asking what the answer to this question is.
Say a lift breaks and the car falls to the ground. If you jump up right before the lift hits the ground, would you still land as hard as you would if you didn't jump at all?
What do you think? Would you still go splat? Your thoughts? Plus any questions on science, technology and medicine, you can email. It's chris@thenakedscientists.com.
The Naked Scientists Podcast. Powered by UK Fast, the UK's best hosting provider. On the web at ukfast.net.
Now, food for thought indeed here, guys. Who would have thought that eating diet food could potentially make you fatter? But that's the story that's been found. David Pearce is at the University of Alberta, and they've done some experiments where they fed diet food to newborn rats, and they found that these rats develop a penchant for overeating as they get older. And sounds counterintuitive, why should that happen? But they've come up with a pretty plausible theory as to why it might be the case. What they think is that when you're very, very young, your brain learns to associate how sweet something is with how many calories there are in it, so that you then use that as a measure of how much you're eating later, and the brain then says, I've got enough calories on board because I've had this much sugar, turn down my appetite. Because when you take diet food, of course, you're not getting any kind of calories, but you're taking in lots of sweet things. And so this programs the brain and fools it into thinking you're being fed more than you really are. But then when you're a bit older and you have non-diet foods presented to you, then you mean you don't have the same restraint because you've learned that there's no calories in them, so it doesn't switch the appetite off. They say it doesn't apply to adolescent rats when you put them on diet foods. It only seems to apply to youngsters. So he's saying the same thing could happen in humans. It kind of ties in very well with studies that have been done at the University of Massachusetts, where they've shown that kids who drink a lot of fizzy drinks that are very rich in these diet supplements and artificial sweeteners subsequently turn out to have high levels of obesity, diabetes and heart disease. So there's an association there in humans. And he's saying diet foods are probably not a good idea for growing youngsters.
So it's just with sweeteners, it's not low-fat foods?
No, he's saying what we should be feeding kids is a good, healthy, balanced diet. But feeding people artificial sweeteners could be subverting the way in which your body works out how much it's taking in the way of energy, and therefore how much you should be eating.
Cool. If you're up late tonight and you look up, you should be in for some cosmic fireworks. The Perseid meteor shower should reach its peak early tomorrow morning, and you should see up to more than one or two meteors in 1 minute. Shooting stars coming in 1 or 2 a minute. They're really great shooting stars.
From all over the sky?
They look like they're coming from the constellation of Perseus, which is over in the east in the morning. But that you should be able to see them anywhere in the sky. They just look like they're all coming from one place. And this year it coincides with a new moon, so the sky should be particularly dark, especially if you get out of a city or a town. And so they'll be really, really visible and should look really good.
Where are they actually coming from, Dave?
They're actually coming... what they are is little tiny lumps of dust coming off the back of a comet. A comet which this lot come from is called Swift-Tuttle. And this year we should hit a really dense patch of them, actually from when it went past in 1862. So there's lots and lots of dust there. And each time they hit the Earth, they hit us at about 130,000 miles an hour. And when they hit, they get really, really hot in the same way as if you rub your hands together, they get hot. But if you rub your hands together at 132,000 miles an hour, they get really,
That's
really
pretty
hot.
fast hand rubbing. So this is literally particles that are falling in through the Earth's atmosphere and getting... Because it's like running into a brick wall, I guess, isn't it, when you get particles slamming into the Earth's atmosphere at that kind of speed.
And they just get incredibly hot. And in the same way as when your cooker ring gets hot, it goes red. If it get really hot, it went orange, and then it gets so hot it get white. These just get incredibly hot, go bright white and glow and produce these great streaks.
Do any hit the ground? Are we in danger?
Occasionally bigger lumps might hit the ground, and you actually call them meteorites, but most of them are so small they wouldn't ever hit the ground.
And is this just going to be in this part of the country, or will people all over the world be able to see it?
Everywhere, all over the world you'll be able to see it. I think particularly good in America, kind of late at night, because it's peaking at sort of 6 o'clock in the morning, so it'll be starting to get light here. But anywhere where it's dark tonight, you'll be able to see it.
Hopefully it will be dark tonight in most places, apart from, of course, in the polar regions, in South Pole, North Pole, where it's nice and bright at the moment.
Absolutely. I just got back from Orkney, and it did get dark, but there was definitely sun, sort of the horizon kept quite bright. It's clouds going to get in our way, though. Because
in Orkney, I mean, when I was in Scotland, you just... It takes a bit of getting used to, doesn't it?
Oh, it's great. You're thrown out. You're thinking it's earlier than it really is, because it couldn't possibly be that late. That light still so late. But no, fantastic. I shall be out hoping there's no clouds in the way of me seeing these meteorites tonight. But heading back down onto Earth, we often hear about coral reefs being the rainforests of the sea. These habitats both are packed full of thousands of species, and sadly both are being lost at ever more alarming rates. But this week we've heard a piece of really bad news for the coral reefs, because they may be disappearing much more quickly than we thought they were, and maybe twice as fast as the rate we generally think that the rainforests are being lost. And that's according to a new study from John Bruno and Elizabeth Selig at the University of North Carolina in the United States. Now, they collected together over 6,000 other studies going back to 1968 that documented how much hard coral was growing on particular coral reefs in the Indian and Pacific Oceans, and that's in countries including Indonesia, Australia and the Philippines.
Hard coral, that coral with an attitude.
Yes, that's right. So it's they're also known as Sclerotinia. It's one type of corals. There's some that don't have sort of a hard body that they live in. They're soft corals. But these hard corals are the building blocks of reefs. They provide the main structure and the habitat for all the other animals and plants to live in. And measuring the percentage of reef that hard corals cover is one of the best ways of gauging how healthy a reef is. It's really accepted as like the standard way of figuring out what's going on and how things are going. It's a bit like looking at the canopy cover of a rainforest. If it's going down, then that's a really bad sign.
But why is it going down?
Well, first of all, I was going to say how much it's going down by. The bad news is it looks like in the last 20 years we've had a drop in around about 1% a year, every year, in the Indian and Pacific Oceans, which is about 1,500 square kilometres. Now, why is that happening? We don't know. That's not what this study looked at, but there's various things it could be. We can't say it isn't global warming. It probably, to some extent, almost certainly is. Increased sea surface temperatures and bleaching. We've talked about how corals lose their algae, and a lot of them will die. So that's one thing. You've also got overfishing, you've got sediments, you've got pollution, you've got all these different factors that are affecting reefs. And the crazy thing is, this is happening over huge areas. It's not just some bits that are going down. It's just a region-wide effect.
So what will be the cost of this, both the environmental terms and human costs, because people get their income and their livelihood comes from reefs.
Reefs are absolutely vital habitats. They only cover... The thing about compared to rainforests, they're actually much more rare than rainforests. So we're not only losing them more quickly, but they weren't so abundant to start with in the first place. But they're hugely important. You can put figures on it if you like, but you might say they're actually they're priceless. They protect coastlines from storm surges and from erosion. They provide huge numbers of people with protein, a source of protein. They also provide income from tourism. And we can't overlook how important things like diving tourism is for countries that have little else to produce money. So they're hugely important. That's despite all the species that that harbour them. And we might find useful things we can do with them in the future if only we can hold on to them. So it's not great news, but it's not all bad news. The study did show that some reefs are actually increasing as well. They haven't completely lost their ability to grow back. So I think we can say if we can reverse some of these problems, these threats, it's not too late.
Let's hope so. Another reason why we might be terribly concerned is because the Earth might be clobbered by something enormous. Dave was talking about meteorites coming in and giving us a lovely, spectacular light show, but you wouldn't want something on the scale of what did for the dinosaurs about 55, 60 million years ago. Thankfully, there is another answer that's been put forward this week. This is actually the brainchild of Daniel Fargian, who's from the University of Rome in La Sapienza. What he's suggesting is we make a nuclear-powered asteroid drill. Simple as that. It's a very real threat that we could be hit by something, because there's an asteroid which is called Apophis, and it's due to make a very close pass of the Earth in 2029. It'll sort of go by a gnat's whisker. No chance of it hitting then. But what scientists are worried about is that the gravitational forces as it goes by and interactions with other bodies in the solar system could distort the path of this asteroid a little bit, so that when it comes back on its return trip in 2036, it could be on a much closer Earthbound course. So we need to have ideas for how to deal with this. And what Daniel Fargeon's suggesting is that you can build this nuclear-powered drill, which you would send off into space. It would dock with the asteroid, and it would be like a massive Black & Decker. It would drill into the surface of the asteroid, and as it did so, it would exploit Newton's third law, which is for every action there's an equal and opposite reaction, because it would spit the rock it was drilling out the back of the drill in the opposite direction, and this would give the asteroid a push in the other direction. And he's calculated that you could move a 1 kilometre diameter asteroid by 30,000 kilometres over a 10-year period. So we've got 36 years to worry about it, so it might be enough time to build one of these things. Not everyone's sent on the idea. Some people have suggested, may you not have a problem because asteroids are spinning, and therefore you've got to program your drill to turn on and off, so it only spits out the rock when the asteroid's pointing the way you want it to go the other way of. Otherwise, you're going to end up spitting rock in all directions, and it just won't change its course. Yeah, and other people are saying, isn't this just too technically demanding? Let's just nuke the asteroid if it comes this way. But that's a problem, because then you create 2 asteroids and you hit 2 cities on Earth instead of just 1. But he's undeterred and says we need to build prototypes, and he's suggesting that a good place to start would be to test the mining and screwing system on the Moon, where it could dig some tunnels out on the Moon's surface, just on the off chance that any humans want to go up there and live on the Moon. This would make an ideal habitat for them.
Marvellous, marvellous. Why can't you just use the nuclear device to create some kind of huge jet engine just to push the asteroid the other way? Why does it have to be a drill? Why can't it just be a...
Well, I think that the problem is that you could, if you mine the hole out of the asteroid, there's 2 things achieved there. One, that you've got a ready source of material to chuck out the back, so you're not actually depleting your own energy resources. Because if you create force from a nuclear engine, that's a lot of force you've got to spit away in terms of the weight you've got to move the asteroid. This means that you're not depleting your own reserves to do that. It limits the size of the device you've got to send. And secondly, you're also making the asteroid lighter in the process, so if it does still hit the Earth, it's not going to hit the Earth quite so hard as it might do.
It could just chip away at it, make it much, much smaller, then it won't be quite...
I think you'd probably be throwing a very small propulsion of it away, actually.
OK, well, I'm coming back down to Earth again, because I haven't given up on this planet yet, even if you guys want to go and live on the Moon. And I don't mean to be the harbinger of bad news, but it does so happen that this week we've had another piece of important and I think incredibly depressing news from the aquatic world, because it looks like we might have to wave goodbye to the Yangtze River dolphin in China. That's because researchers from the Zoological Society in London have reported that during 2 months of a very thorough expedition to the Yangtze River, they found absolutely no trace of these rare dolphins. Now,
they're even rarer now, aren't they?
Well,
but tell us a bit about them first. What actually are these animals?
Great. OK, well, what were they?
Were these animals?
Probably were, unfortunately. They're a river dolphin, so they lived in the freshwater in the Yangtze. I think they're a couple of metres long. They've got these long beaks. They had these long beaks. They look quite odd. In fact, I don't know if any of you have ever read, I've got a book here called, by Douglas Adams, that great science fiction writer. You may know The Hitchhiker's Guide to the Galaxy. And he wrote this book called Last Chance to Sea years ago. I think 15 years ago he wrote this with zoologist Mark Carwardine. And he went around the world looking for endangered species that were still clinging on, but to see how they were doing. And the Yangtze River dolphin is one he tried to go and find. And it describes he went to the river and looked around, and he didn't find one either, but he met a lot of scientists, and at that stage there was one in captivity. But one of the scary things is that these creatures represented the very last member of a group of mammals that split off from all the other marine mammals, possibly around 20 million years ago. So that's it. These have all gone now. There's nothing left on this branch of the evolutionary tree.
Have we got any DNA samples or anything? Could we conceivably recreate them if we master cloning or something?
We could possibly. I suspect there might be some hanging around, but I don't even think we do, actually. And that's, even if you had that technology, that's miles off. So really, they were quite a unique creature. They were actually they were part of ZSL's EDGE program, which was the Evolutionary Distinct and Globally Endangered Species program, where they looked at all the mammals and saw which ones were most distantly related to each other and also the most endangered. So possibly the ones we should be looking after. But this one we didn't. So I think it raises a lot of questions. I wondered if anyone at home, any of our listeners, had thoughts about, does it matter that there are none of these things left? I don't know how you guys feel about it. And they were beautiful creatures, and it's probably the first example of a big vertebrate that's gone extinct in the last 50 years. So the first one that we can really say it's gone. Since our lifetimes, there's none left, and that's pretty sad, I think.
Maybe it's a taste of things to come. I hope not. It is The Naked Scientists with Chris, Helen and Dave. It's our Q&A programme. We're taking any science question that you might have for us. You can email us, chris@nakedscientist.com. In a second, we'll be talking to Ian. He's in Tillingham and he wants to ask us about heart rates and things.
The Naked Scientists. Supported by the Wellcome Trust.
Hi Ian, you're on The Naked Scientists.
Hello, is that Chris?
Yes, it is Ian. What do you want to talk about?
Chris, I wonder if you could help me, please. I'm getting on a bit, and I've got quite a high heart rate. Mind you, I do quite a bit of training, that sort of thing. Would that be normal?
Well, it depends how high your heart rate is, and also whether you're drinking lots of coffee, drinking lots of alcohol. There are lots of things that can put your heart rate up. Sometimes having a fierce argument with your wife is enough to put most people's heart rates up. So I can't really comment on individual cases, Ian, but the way in which your heart works is that it's supposed to match the rate at which it beats to the demands of your body so that the right amount of blood is pumped out, because you don't want to be pumping too little blood because then tissues are being cut off and starved. At the same time, you don't want to be pumping too much because then you're wasting energy. And there are some conditions that can make the heart go a bit too fast. Usually they don't cause the heart to be fast all the time, fast and regular all the time, unless there's something quite serious wrong. Be unusual for you to have that. But if you have got a high heart rate, maybe you should go and check yourself out with your GP.
Right, no, it's just that, I'm getting on a bit. I'm near retirement, and although my resting heart rate is about 44, 46, when I'm really working hard, really pushing myself, I can still go up to 190, 195.
Well, that sounds like you're fighting fit to me, because people who play in the World Cup at football, I was looking at some of the data
I'm
people...
nearly 60.
Well, I'm saying you're fighting fit, I think, because I was looking at the data for referees and people who were being checked out for a World Cup a few years back, and they were putting them all through cardiovascular tests to make sure they weren't going to have some kind of problem when they were on the pitch playing in an international game, and they were running out heart rates of 45 resting. So I think you're in pretty good shape there, Ian.
So that doesn't matter. It doesn't hurt then to have, work quite hard and be getting on for 60.
No, I think what you have to do is to do what comes naturally to you. And if you start to get symptoms and start to feel unwell, that should be a sign that you're doing too much, overdoing it. But if you do what's comfortable for you, you should be fine.
Oh, right then. OK, this Chris, right.
I don't think there's any easy way of saying there's this rule you have to follow at any given age. It's a question of, I think, you are as old as you feel. It sounds like you're doing all the right things, Ian.
Oh, all right then, Chris.
Good to have you on the programme.
Yeah, thanks for helping us out.
You're welcome.
Much obliged.
Take care.
Now it's time for this week's Kitchen Science. Ben is investigating a question about some very special bubble bath with some rather unusual properties.
Hello, welcome to Kitchen Science. Last week I took you into my kitchen where I made some nettle tea and tried to avoid being stung. But this week I've brought you into my bathroom because we've had a call in from Neil in Coventry.
Hi, I'm Neil. I'm in Coventry in the UK. I look forward to listening to the Naked Scientist podcast. Recently I bought some Matey bubble baths for my kids, and when he pour into the water it changes from red to blue. I couldn't work out why this was. I was driving my wife up the wall trying to understand what was going on. Hopefully the Naked Scientist can answer this for me. Thanks.
So, Mr. Matey Doctopus Bubble Bath, does it really change colour? I thought we'd find out. So I've got Rosie Hunt here from the University of Cambridge's Chemistry Department, and she's going to put it through its paces. Hello, Rosie.
Hi.
I see you've got a bottle of Mr. Matey there with you. What does it claim to do?
It calls itself Doctopus Matey Bubble Bath, and it changes colour in the bath.
All right, then, well, let's run a bath and get it tested out. So, Rosie, while the bath's running, why don't you pour some out into the lid and let me know what it looks like?
Well, I'm pouring some out, and it's a sort of red colour, sort of deep red colour, and fairly sticky, viscous sort of a liquid.
It also looks a bit like strawberry syrup, something you might put in your ice cream, perhaps.
It does.
Well, let's get some in that bath and see if, indeed, the colour does change. OK, then, so we've got this really red, sticky bubble bath stuff, and we're going to pour it into the bath and see if it does indeed change colour. Rosie, if you wouldn't mind?
Right, here goes. Oh, it is changing, isn't it?
It's immediately gone blue. It's gone quite a rich sort of inky blue in there, actually. But I'll just mix it up a bit and see if the whole thing goes.
And the whole bath is now, in fact, blue.
OK then, people at home, if you think you know why this bright red bubble bath has gone blue as soon as it hit my bathwater, then please call in and let us know. We will come back to you later in the show and we're going to try and work out how it works.
So if you think you know what it is that causes Mr. Matey to change from red to blue when we put it in the bathwater, then why don't you let us know? Email us, chris@thenakedscientist.com.
And Frank's in Whitford. Hi, Frank.
Hello there.
You've got a question for Dave.
Yep.
Fire away.
The question's about the moon. When you see a full moon low in the sky, it appears very large compared to the full moon when you see it directly overhead. Now, it was suggested to me by somebody that this was just a matter of perception. When it was low on the horizon, you had things to compare it with, and it looked bigger. When it was overhead, you didn't. I couldn't swallow this, to be honest, and I felt that it was the fact that we were looking through a much thicker layer of atmosphere when we were looking at it low on the horizon.
If it's low on the horizon, you are looking through more atmosphere, and actually that's why sometimes it looks orange when it's very low in the atmosphere, in the same way as when the sun's very low in the atmosphere will scatter out the blue light, and so all that you get through is kind of orangey and red colours. And if it's right on the horizon, it could distort its shape a bit because the atmosphere is curved. But it wouldn't distort it evenly, and it wouldn't magnify it evenly. The reason why it looks big is basically an illusion. If you looked at it through a toilet tube so you couldn't see anything around it, it would look the same size as it does up in the sky.
So it is a matter of perception.
Yeah, it is a perception thing. Your brain sees lots of things which it knows are quite big near it. So like trees and houses. So it thinks, the moon must be enormous. But if you look up really high, then it looks there's nothing to compare it to. So it just looks the size it is, which is quite small.
Thank you very much, Frank. That's a good question.
All right, thanks a lot.
Great to have you on The Naked Scientist. If you've got a question for us, email chris@nakedscientist.com.
We've had an email here from Chandra Saligram in Bangalore in India. She says she loves to listen to the podcast, gives it company on the way home during those huge pile-ups in peak hours in Bangalore. It just sounds wonderful and so far removed from our little studio here in Cambridge.
Not so far removed from Cambridge, though, where the traffic is absolutely appalling.
Oh, that's true, possibly, yes. But anyway, her question is, when you are all by yourself with no external disturbances, you hear a humming sound which appears to emanate from your head or somewhere in your body. What's the source of this droning sound?
Well, there are two things that jump to mind with this. Noises that come out of nowhere and involve your head could be tinnitus, which is when you have damage to the hearing system, you remove the input of certain parts of the hearing spectrum, because you hear different frequencies at different parts of the auditory spectrum, and they send those signals to the brain. And in the same way as if you chop off a leg, you can have phantom pain. You can still feel the missing leg and it really hurts. Well, some people have suggested that tinnitus is where you divorce part of your cochlea or damage part of your cochlea. The brain doesn't get any input from that bit of the ear, so it says, I'll invent some sound, which I should get. Although that's normally a high-pitched ringing noise, so it doesn't sound like what he's saying. The most likely thing is that you have blood vessels that run through your ears and through your skull, and when you put your head against the pillow, you create a nice echo chamber between your ear and your eardrum, and the pulsation of blood vessels opening and closing in the skin makes that sort of squelching
yeah, I know,
noise.
I've had that, yeah.
And that's blood vessels pulsing. You're hearing blood whooshing in your own blood vessels, so that could be what it is.
Could be that. OK. I hope that helps answer your question. Thank you very much for your email.
One here for you, Helen. This is from Tad Davidson. He's in Cambridge. He says, great show. I'm now a regular listener to BBC Radio Cambridgeshire thanks to your very entertaining programme. I recently heard a statistic quoted on a television programme that concerned me greatly, but I haven't been able to verify its accuracy. It seems that 90% of all big fish in the sea have disappeared in the last 40 years. Obviously, this can be reversed, provided that fish stocks are left to recover and provided certain species have not become extinct in the meantime. It's pertinent from what you were saying earlier about dolphins. I know they're not fish, but he says, is this down to overfishing, or is there a more scientific explanation for the decline, perhaps related to global warming?
You're absolutely right there. We have had declines up to 90%. If you want to find out more about it, actually, you could probably just tap the name Myers into Google Scholar, because there's a chap called Ransom Myers who sadly died this year, who's done huge numbers of studies looking at how much we've changed what's living in the oceans. And it's incredible to believe we have actually, and it is overfishing. We think that it really is the culprit. We're fishing far too many big fish, tuna, sharks, those kind of things. It's incredible the effects we can have. And I do hope we can just stop fishing them and they can recover. That's one big question as to whether fish stocks will recover. there may actually be such fundamental changes in the system that might not happen. So for cod, for example, you might have heard that there's really not many cod left in the sea, especially near Canada, in Newfoundland. There was a big crash. The fishery actually closed in the 80s because there were just not enough fish left. And that's actually, it's coming up to 20, 25 years ago, more than that, and they still haven't come back. So what's the problem? We're still not fishing them. But it could be a shift that they're actually, there's now more predators on the juvenile of any of the fish cod that managed to make it through are being so heavily predated on because the adults aren't there to eat the fish that would eat the babies. We've messed around so much with the system that the babies just don't have any chance. So it really is quite a big problem. But read up on it if you want to. As I say, go to Google and find out more. But it's a big, scary thing that we can make such big changes just by the fish that we want to eat.
Dave, got one here for you. It's Cameron Patterson. Says, I love your podcast. I listen to it every day. I'm 9 years old and I've got a question. Why is it that when you touch a magnet onto a computer or television screen, it turns it different colours? And why do the colours sometimes stay? Thanks and respect, Cameron Patterson.
Wow, respect. OK, for this you've got to understand how the old-fashioned TV screens or computer screens work. The way they work is they have a gun, they have a big chamber of glass, and they suck all of the air out of it, so you've got a vacuum. You have a sort of electrical gun at the back, which fires things called electrons, which are the things in a wire which transfer the electricity around them, fires it down through the tube, through the whole of the TV, they hit the screen. On the screen you've got little lumps of a substance called a phosphor. Now that glows when it gets hit by an electron, and that's the light you see. Now, if you just covered the whole screen with one colour of phosphor, then you'd have black and white TV or green and black TV or whatever you like, but you don't get the funky colours. So what they have to do is they have to have lots of little spots, one of red, then one of green and one of blue. And with red, green and blue phosphors, you can join them up to make all the colours you can see normally, because that's the way your eyes work. Now, these electrons flying through can get distorted if you put a magnet near them. That's actually how they make the picture.
I didn't realise electrons necessarily are susceptible to magnets then.
In the same way that a wire with an electric current running through it will get moved by a magnet, electrons flowing in free space near it with a magnet near them will get bent.
So you suck some of the coloured stream that would normally activate a different colour onto that part of the screen. So I understand that. Why does it stay?
Well, OK, so they're getting distorted because you're applying more magnetic field than it should be, so they end up in the wrong place. But you can actually magnetise the TV itself. So they're getting distorted always, and it could keep going there. In fact, you may have heard TVs kind of go buzz sometimes when you turn them on.
Yeah.
It's kind of sound as they turn on. And that's actually, they have something called a degaussing coil in them, which is a big coil of wire around the TV, and which you put high-frequency electricity through it, which starts off really powerful, so it sort of entirely confuses the TV's magnetisation. It doesn't know which way to go.
It's supposed to demagnetise the screen, and if that breaks, is that why you get screens which develop funny patches of colour on them sometimes?
Yeah, if it's entirely broken, then
the screen gets magnetised over time.
If you get a TV which is running and you turn it upside down while it's running, you get really weird colours as well, because the Earth's magnetic field is enough to distort the electrons.
And the TVs are built, presumably, to be operated the right way up.
Well, if you turn them off and then turn them on again, then the degaussing coils would run and it would reset itself,
but it's got to be on and running when you turn it over. So what would happen if you took it into space?
It depends. I guess why particularly in space.
Well, the Earth's magnetic field is weaker, out in the middle of nowhere.
Well,
so.
if you turned it off and on again, then the degaussing coils would set it up as it would expect, and it will work again.
Let's hope so. Got a quick input from Austin. He's in Chelmsford. He was commenting on the kitchen science. We asked you if you knew why, and we're investigating why Mr. Matey Dr. Pussy, when you put it in water, it starts off red and it goes this really funky blue colour. Why is that? He says it's got something to do with the alkalinity in the water. The area has a very high calcium level in the water, and he's noticed when washing out certain juices, their colour changes quite dramatically. So, yes, that sounds like it could be plausible. What do you think? If you have any science questions for us as well, you can email us, chris@nakedscientist.com.
The Naked Scientist Podcast, brought to you by thenakedscientist.com.
You're listening to The Naked Scientist. Now, you might not consider looking to cartoons to help you keep you up to date with science, but you could do much worse than watch an episode of The Simpsons. The people behind the Nature podcast took a look at the science in Springfield and found out that it's better than you might think.
If you're looking for science on TV, you probably wouldn't turn to a show about a dysfunctional cartoon family whose main intellectual thinker is an 8-year-old girl. But if you look closely, The Simpsons is one of the most scientifically literate shows around. And that's perhaps unsurprising, given the fact that the show's head writer, Al Jean, studied mathematics at Harvard. I asked him whether there are any parallels between cartoons and maths.
I look at comedy writing mathematically. it's sort of like a proof where you are trying to find the ideal punchline for a setup, and when you get it, it's a very elegant feeling, and it is a little like the feeling I would get completing a proof when I was doing math in college.
And he's not alone. In fact, most of the established writers on the show have a scientific pedigree, and it's a pretty impressive roll call.
Yes, Ken Keeler, who wrote for The Simpsons and Futurama, has a Ph.D., mathematical Ph.D. Bill Odenkirk, who writes for The Simpsons, has a Ph.D. in chemistry. George Meyer, a longtime Simpsons writer, was a science... I can't remember what his major was, but it was definitely in the sciences. And Stuart Burns, another Simpsons and Futurama writer, had math degrees. And, you know, when we're alone, you know, we sort of talk about math. But again, we've learned that there's a wider world, and we don't always expose others to it, or we do it in a subtle way.
I know. And this perpetual motion machine she made today is a joke. It just keeps going faster and faster. Lisa, get in here. In this house, we obey the laws of thermodynamics.
There's also a scientific theme running through the new movie. Alongside typical Simpsons absurdities, such as Homer falling in love with a pig, the plot also features the looming threat of climate change, prompting Lisa to present an Al Gore-style lecture entitled An Irritating Truth. In fact, throughout the show's 400-episode history, it has often fallen to Lisa to speak up for scientific rationalism, perhaps most notably in the episode in which she attacks Springfield's decision to abandon the teaching of evolution. It made me wonder whether the writers have a specifically pro-science agenda.
Our general agenda is to display both sides of an issue and to let the viewer make up his or her own mind. In that particular case, I believe evolution is so scientifically well-founded that it's hard to have any sort of intelligent alternative to it.
Creationism? But that's not science.
It is now. This helpful video will evade all your questions. Screen word.
So you're calling God a liar, an unbiased comparison of evolution and creationism. Let's say hi to two books. One, the Bible, was written by our Lord. The other, The Origin of Species, was written by a cowardly drunk named Charles Darwin.
Yeah. This is slander! Darwin was one of the greatest minds of all time! Then why is he making out with Satan?
Of course, The Simpsons also has fun with scientists' social image, especially in the case of the painfully awkward Professor Frink, who one suspects would trade in all of his inventions, such as the sarcasm detector, the frog exaggerator, and mood pants, for the chance just to get a girlfriend. But more seriously, and as someone who has spent time in the scientific community, Al Jean worries about the negative portrayal of science and scientists in much of the mainstream media.
And it's sad because, you know, in my life I've seen science viewed as sort of the savior for everything, and it's almost come full circle where, you know, because nothing can completely solve everybody's problems, the disappointment when that happens is extreme, and now people are, you know, casting scientists as villains or, you know, not listening to them, which I think is tragic. You know, 50 years ago, Albert Einstein was the epitome of scientists among the public and regarded as a hero, and there isn't anybody comparable today, and I think it shows how science is, you know, been made by some to appear in a, you know, more ambiguous light.
That's not to say that contemporary scientists haven't appeared on the show. Over the years, The Simpsons has featured scientific luminaries such as Stephen Jay Gould and Stephen Hawking, and the writers haven't been afraid to give them scripts that delve into the relevant subject matter.
There is nothing, you know, purer than mathematics in anything, of all the things I've ever studied. People seem really thrilled that we've had Stephen Hawking on the show, and no one could be more thrilled than I.
Stephen Hawking! The world's smartest man!
What are you doing here?
I wanted to see your utopia, but now I see it as more of a fruitopia.
I'm sure what Dr. Hawking means is...
Silence. I don't need anyone to talk for me, except this voice box. You have clearly been corrupted by power. For shame.
Larry Flint is right! You guys stink!
I don't know which is the bigger disappointment. My failure to formulate a unified field theory, or you.
So if you worry about science getting a bad rep on TV, you can take solace in the fact that Springfield, at least, is on your side. That's assuming, of course, that you think science is worth caring about.
Science? What's science ever done for us? TV off.
That was Mike Hopkin from the Nature Podcast talking with Simpsons writer and Harvard mathematician Al Jean. And incidentally, the Simpsons movie is out in cinemas near you right now if you want to go and see it. I've seen it and I thought it was great fun. Have you seen it, guys?
I haven't been yet, but I do quite like the Simpsons.
I think you should.
So.
We were all giggling here in the studio, so I think you should pay a trip and have a good laugh, I think.
Now, what's science ever done for us is also the title of a new book that's out at the moment. It's been written by Professor Paul Halpern. He's from the University of Philadelphia. He joins us now. Hello, Paul.
Hello, Chris.
Thank you for joining us on The Naked Scientist. Tell us about your book. Why have you written this? And don't say to make money, because that was Boris Johnson's answer on Radio 2 the other day.
Well, I noticed throughout the years, as Al Jean pointed out, that The Simpsons features marvelous scientific references on the show and features scientific guests and many allusions to people such as Niels Bohr, Einstein, Darwin, and Newton. And I thought it was time to look at The Simpsons episodes and explore the real science behind the series.
Well, to give people a sort of insight into how you've done this, it's nice, this, because you get the taste of The Simpsons up front, and then you get the how is this relevant to science at the second part of the chapter.
That's right. In each chapter, I look at how an episode of The Simpsons handles the science, and then I look at the background behind it. For example, in one episode, Lisa invents her own perpetual motion machine, and Homer gets upset by it and shouts at her, "Lisa, in this house we obey the laws of thermodynamics." So I take off from that episode into an exploration of whether or not perpetual motion is possible, and I explore the laws of thermodynamics. So I find that it provides a great intro into some interesting science.
How does The Simpsons actually sit with you as a professional physicist engaged in research in a US university?
Well, physicists, those who watch television, tend to enjoy series like The Simpsons because it's one of the few series, if not the only series, to have scientific references on the show. And it does a number of fun and very sophisticated things with science. For example, exploring higher dimensions, looking into the possibility of time travel, bringing up genetics, robots, artificial intelligence. It's just amazing how much interesting science there is on the show.
I thought it was hilarious when Homer Simpson manages to end up crossing a tomato and a tobacco plant to make an addictive form of a tomato.
That's right. It's called tobacco, and the interesting thing is he uses plutonium to try to make this hybrid.
And he gets it where?
He manages to get it shipped in from his nuclear plant. It's no problem for him since he works at the nuclear plant, so he just manages to phone up his friend and get some plutonium shipped into his farm that he's trying to grow crops on. And then he grows this tobacco and produces tobacco pies, which are highly addictive.
Now, I don't know if this is in your book, but one of my favourite bits in one of the shows is the episode where they discover that Homer, as a young child, pushed a crayon up his nose and into his brain, and that's why he's Homer, shall we say. And they take it out and he becomes very intelligent, and then they decide in the end to put it back again. Do you think, is there any reality behind having a pencil in your brain and changing your behaviour?
Well, it's interesting because The Simpsons brings up a number of theories throughout the years on why Homer is so different than other people in his family. For example, Lisa, who's much brighter. And in one episode, they attribute it to genetics. And then in this episode called Homer, which is a parody of Flowers for Algernon, they suggest that it's an accident that Homer had as a child where he had the crayon lodged in his brain that affected his intelligence. But the strange thing is, once they pull out the crayon, he's very unhappy, and he prefers being not so bright.
I think that goes for a lot of people in some cases, though, doesn't it? I mean, not that everyone would have a crayon jammed up their brain, but some people find that there is ignorance is bliss, isn't it?
That's right. Sometimes you can know too much about a subject, and you might not be happy about it. You'll be well informed, but perhaps not particularly happy about, if you know that something dire is going to happen.
Well, Paul, I have to say I've thoroughly enjoyed reading your book. I had me sniggering at midnight last night, so thank you for sending us a copy. Thank you for joining us on The Naked Scientist to tell us about it. It's out now, is that right?
That's right, yes. Well, thank you very much, and my pleasure.
It's been a pleasure to have you on the programme. Thank you.
Bye-bye.
That's Professor Paul Halpern. He's written a book, and it's called What's Science Ever Done for Us? And it's all about how The Simpsons, as we've been exploring, actually has its firm roots in science, and you can get it in all good bookshops right now.
Fancy listening to The Naked Scientists in your bed, on your way to work, or even at work? Why not subscribe to our podcast? For more information, visit nakedscientist.com/podcast.
I've got an email here that's just come in from Eth in Mount Fitchett, I think that's right, otherwise known as Dr. Beaver. Anyway, he says, I've been watching the meteors for the past week, and I live in the country, so there is no light pollution apart from an orangey glow on the horizon from the nearest town. The glow has been there even through the nights when the nights have been crystal clear, so the light isn't reflecting off clouds. So why does the glow rise above the horizon? What is it reflecting off?
I mean, if you can see the glow, then it must be reflecting off something, so there's something scattering. It could be dust in the atmosphere if you've got a very, very, very dry night, but I'm guessing this country, it's more likely to be a bit of moisture. In the evenings when it gets colder, you might get some water condensing in little droplets and forming something a bit like fog, but probably much thinner than fog, so you wouldn't actually see it in normal distances. But over a distance of a kilometre or so on a very dark night, you probably see the street lights bouncing off it.
Thanks, Dave. Got an email here from Isabella, Izzy, and she says she's in Australia. She's 7 years old. She listens to us on our podcast, and she says, Dave, what makes a cake rise? What would happen if I just used normal flour?
In the self-raising flour, they've got something called baking powder, and this is a mixture of a couple of things which give off gas. There's normally some bicarbonate of soda in there, and to start off with, you'll have some tartaric acid, which is an acid, and as soon as it gets wet, the water will turn it into an acid. When it's dry, it doesn't work. Then that will react with the bicarbonate of soda, like if you added vinegar to it. It produces bubbles, and those bubbles will make the cake rise. They also add some other stuff which will make bubbles when it gets hot, so you get more bubbles when you actually heat up the cake.
And so you get the bubbles, they take up space and expand the dough.
Yeah, sorry, the bubbles are made out of carbon dioxide, which I didn't mention earlier.
I've got an email here from Gobi who says, our shows are really good. Thank you very much. Listen to them every day on the bus on the way to school. And the question is, what information do you get from the CT images of the brain, and how do you read them?
Oh, CT was really a massive breakthrough in medicine because it gave us the first three-dimensional views of the inside of your body without having to open someone's body up to take a look inside. They rely on X-rays, and where a plain X-ray just shoots a beam of X-rays through your body, some tissues soak up more X-rays than others, and then you have a piece of photographic film behind the body. All you get is a shadow, if you like, of some of the things that soak up more X-rays than others, and you have to try and read that. But with CT, what it does is shines X-rays through the body at multiple angles. In fact, the whole arrangement turns around the body. So it shoots X-rays through you from every single possible angle, and it's taking a picture at every one of those things, and a computer then pieces together how much the X-rays were soaked up by all of the bits of tissue that it went past on the different paths as the X-rays went through the body from different directions, and it's able to build up a three-dimensional picture of what you look like inside based on how the X-rays were soaked up by the tissue. You can make it even more sensitive by adding things called contrast. This is heavy atoms of things like iodine or barium that soak up X-rays, and this can help to create a contrast between, say, blood vessels and other tissue, so you can image things even better. But it's very, very useful in things like stroke. You can look in the brain and see if there's a blood clot or a bleed, because blood has got a lot of iron in it, and the iron soaks up X-rays, and it shows up as a big white hotspot if you've had a brain injury and you've got some blood outside the brain or something. So CT, very, very useful.
I've just got we had a call here from Dave in Bradwell, who used to be a trawlerman. So that was on my topic of fisheries. And he says what people don't realise is that the average size of a trawl's mesh, so that's how big the holes are in it, is 2.5 inches. So that once a fish is caught, it's killed. So if fish are caught that are too small, they need to be thrown back, and the damage is already done. And he suggests that protected areas might be a good option, although, of course, you've always got the issue of poaching. And you've nailed it on the head, really, Dave. That is the thing we need to aim at, is putting aside parts of the ocean where we don't do anything, we don't take any fish from them, to hopefully let those stocks recover. The problem is, though, we've only got a tiny amount of the ocean currently protected, about less than 1%, and we really need to be aiming at around 20%, so we've got a long way to go.
Laying the facts bare, The Naked Scientists.
It is The Naked Scientists with Dr. Chris, Dr. Dave and Dr. Helen. It's our Q&A programme, an extravaganza of your science questions. If you'd like to get in touch with us, email chris@thenakedscientist.com.
Now it's time to join Diana O'Carroll for this week's Elevating Question of the Week.
Hello and welcome to Question of the Week. Here's a question for all of those action movie fans out there. Linda from Harrogate wanted to know.
Say a lift breaks and the car falls to the ground. If you jump up right before the car makes contact with the ground, so you would be in the air when the lift hits the ground, would you still land as hard as you would if you didn't jump at all?
Is it possible to survive from a tumbling lift? Mechanics expert Alan McRoby from the Department of Engineering in Cambridge had this to say.
Okay, so you're in this falling lift, and the question is, should you jump, and would that help? It's quite an old question, and I think the basic idea is that you're falling down and you jump yourself upwards, and the relative velocity you give to yourself is sufficient that you can just sort of walk out. And basically, it is possible to do that, but provided the lift only falls as high as you can jump, from about a foot above the ground. If you're falling from, say, a 5-storey building, you'd have to be able to jump as high as a 5-storey building, and we can't do that. If you fall from a 5-storey building, you'll be going about 20 metres per second when you hit the ground, which is 45 miles an hour. So it's a bit like being hit by a train doing 45 miles an hour. There's two things you can do in this falling lift. One is you can try and get your body to act as a crumple zone and protect your head, like the sort of front of a Volvo. You'll damage lots of internal organs in the way, but you try and slow your head down from hitting the ground as best you can. But that's not really going to work if you fall from Canary Wharf. So the other thing you can do is enjoy the ride, because it's actually a fabulous zero-gravity laboratory. You could sort of spin your arm round and round one way and see if you can make your feet go up and point at the roof, like a cat spinning its tail, except in reverse. If you're a naked scientist in a lift with another naked scientist, you could try all sorts of other interesting experiments that people always talk about what's possible in zero gravity. So I think that's what I'd try and do. Unless it was a 5-storey building, I'd try and do the crumple zone thing. But if it's a big one like Canary Wharf, I think I'd just enjoy the freedom from gravity, and then it's oblivion.
Emily Eifler from San Francisco added that the velocity of a human jumping up can only cancel out the downward velocity of a falling elevator by a foot per second or so. So whether or not you will die depends entirely on how fast the elevator is falling. Other factors have much more influence on your survival, such as the narrowness of the elevator shaft to create an air cushion, assuming it's airtight, and the spring action caused by a slack cable. So it seems only Keanu Reeves has such superhuman powers. Why do superheroes never take the stairs? Question of the Week is on holiday for the next fortnight, but we're still looking for your questions and answers. On our return, we'll be looking at arm injuries and weather changes. Kat from London wrote in to say,
I broke my elbow when I was younger, and now, when there's a sudden change in the weather, the joint really aches. I assume it's got something to do with the change in air pressure as a new weather front moves into the area, and if that's right, then how would it make my arm hurt?
Do you know why injuries are affected by the weather? Send your answers or new questions to questionoftheweek@thenakedscientist.com. That's all for now. Back to the studio.
Thanks, Diana. There's also a couple of other things you'd have to consider as well. You need to jump at exactly the right time, and who knows how you'd actually be able to time it that well. Also, even if you're an action hero, you need to jump upwards at the same speed as the lift was falling downwards to actually cancel it out. And jumping that hard, you probably hit the roof before the lift hit the ground.
We also had a few emails on this, such as this one from Lewis Stapleton in Kent, who said, just like in a moving car, if you throw a ball into the air, it continues moving up with you. The same could be applied to the lift. Even though you jump, surely the falling lift would still give you velocity, so you would still hit the ground at the same speed the lift is falling. And anyway, surely that lift would collapse under its own weight, so you would be not in a very good state when you got to the bottom. We also heard from Flair Chu in Singapore, who kindly did some maths for us and worked out if you fell 30 metres in a lift and jumped at exactly the right time, you would only still reduce your speed by roughly 2 metres a second, and that you probably still hit the ground at about 80 kilometres an hour, which I don't think any of us would survive, really, would we? So it seems that it's really not worth jumping when you're caught in a falling lift if you were to be so unlucky, but maybe just do that to enjoy that freedom from gravity. But do you know why broken bones can feel a change in the weather? And have you got any old injuries that act as a personal barometer? Well, why don't you let us know at questionoftheweek@thenakedscientist.com.
And we also had an email from Dan Cole, who's Australian but living in Thailand, if you can work that one out, and he pretty much echoed the sentiments of everyone else there. So thank you, everyone who responded to that one.
Sorting out the sparks from the quarks. The Naked Scientists. For more information, get online at nakedscientists.com.
It's The Naked Scientists, Dr. Chris, Dr. Dave and Dr. Helen. We're taking your science questions on pretty much any subject. Now, let's head back to the kitchen to find out how Ben and Rosie got on with trying to find out why this interesting bath foam changes colour.
Welcome back to Kitchen Science. We've now come out of my bathroom and back into my kitchen so that we can work out how Mr. Matey Doctopus Bubble Bath changes colour when it hits the water. Rosie, what sort of things can chemically happen to change something's colour?
Well, the colour of a chemical is dependent on how the molecules in it interact with light when it's reflected or when it shines through. And that's altered by what the structure of the molecule is. So anything that will change the structure of a molecule might change its colour. So if you heat something up, that might change its chemical structure in the same way as you change the chemical structure of your food when you cook it. Or if you add an acid or a base, you might change the structure that way.
So, seeing as heating it up might change it, when we poured this into a hot bath, that made it change colour. So why don't we try and find out if it is in fact the heat? So we've got 2 glasses out of my kitchen cupboard, and we've put a little bit of bubble bath in the bottom of each. And I think we already know that it changes colour when we put it in hot water. So, Rosie, would you mind just putting a bit of hot water from the tap into 1 glass?
And there's hot water. Yes, it's gone blue just like it did in the bathtub.
So now we have a glass of inky water. So shall we try the cold out?
Try the cold tap as well. And that's also gone blue. So it doesn't seem to be a temperature effect.
Obviously it's gone blue with both hot water and cold water, so it's not the temperature that's doing this. Now the other thing that you mentioned was a change in acidity or pH. We've got 2 more glasses with a little bit in here, so why don't we try putting something that's acidic and something that's basic in and see what happens there.
Alright, well I've got some vinegar here. So if I take some of this and pour it into the glass with the bubble bath mixture. Now that's interesting. That's still just as red as it was before.
So when we've poured an acid into the glass, it still stayed red. Do we have something that's alkaline? Can we try the other way?
Yes, we've got some bicarbonate of soda over here. We've put it into a glass full of water so that we can mix it in more easily. So I swirl that round a bit and tip that into the glass. Yes, and there we are. We've got that blue colour change again.
Excellent. So that's gone blue on contact with an alkaline substance, in this case bicarbonate of soda, and yet it stayed red on contact with an acid substance. Is this reversible, do you think? Could we put an acid into the blue one and make it go pink again?
Let's find out.
So we'll now pour a little bit of vinegar into one of the blue glasses that we've got. Wow, that's immediately gone bright, sort of Tizer red again. So clearly this is a pH thing and not a temperature.
Yes, it's a reversible change. When we add acid, it goes to this orange-red colour, and we add bicarb, and it goes blue.
But it changed colour when we put it into water. Isn't water pH neutral?
Yes, tap water's about neutral, but different types of indicator, different chemicals that change colour with pH, will change colour when they're more acidic or less acidic solutions. If the bubble bath is already acidic, then you'd see a colour change as it came close to neutral.
Excellent. Well, we actually have a letter here from Matey themselves telling us exactly how this does work, and I'm pleased to tell you that you were almost 100% right. Mr. Matey themselves has said, the bubble bath contains a dye that changes colour when pH changes. pH is a measurement that describes how acidic or alkali something is. For example, vinegar is acidic with a pH of 2, and a bar of soap is alkali with a pH of 9. The bubble bath in the bottle has a slightly acidic pH, which is similar to the pH of skin at pH 5.5. At this pH, the product is red, and the water in the bath usually has a higher pH. It's more pH neutral, having a pH of about 7. So when the bubble bath is added to this, the dye changes from red to blue. Dyes like this are often called pH indicators, because you can use them to measure the pH of some liquids from the colour change. The Matey bubble bath is specially formulated to be very bubbly, and the formula softens the water, therefore creating a higher level of foam. Well, that's it for Kitchen Science this week. We hope that we've answered Neil's question about what it is that makes Mr. Matey Doctopus bubble bath change colour. If there's anything that you want the Kitchen Science team to investigate, please feel free to let us know by emailing chris@thenakedscientist.com. All that remains is to say thank you very much to Rosie.
Thank you.
And goodbye.
Goodbye.
And thanks to you as well, Ben. And we had a bit more information on that because we had a little look, and the chemical in Mr. Matey that changes colour is actually called bromoscriol green, strangely, given that it turns from red to blue. Anyway, for more experiments you can try out in your bathroom, kitchen, living room, or even in your garden, visit www.thenakedscientist.com/kitchen science.
And John is on the line. He's in Peterborough. Hi, John.
Hello there.
Thanks for joining us. What do you want to talk about?
Right, I was watching a programme the other day on relining the arteries when you've got a problem with them.
Yes.
And how does a stent open out when it's put in there?
OK, what you're referring to is when you've got a blocked coronary artery, for example, in the heart. What people used to do was to stick a line in through the top of the leg into the artery, thread it back to where the heart is, go into the blood vessels that supply the heart, and then you inflate a tiny balloon inside the artery and you open up the artery by squashing the blockage, which is making the artery narrow. When they did that to start with, what would happen is very quickly the artery would block up or fur up again. So then doctors discovered that the best approach is you deploy what's called a stent, which is like a metal scaffold. Now, it's very, very tiny when you first put it in, and it's threaded over the end of the balloon. And when it gets to the right point in the artery where you want to deploy it, you inflate the balloon, which stretches the scaffold, and it's almost like it ratchets out and then locks in position, and it props open the wall of the artery, stopping it constricting again, and this should hold the problem area open and make sure that it doesn't block again.
Right, I got you.
Thanks for having it.
Okay.
Thanks for your question. That was a great question, though, John.
Okay, then.
Good to talk to you.
Cheers, then. Bye.
Bye. Dave.
A question for you, Chris. Basically, Steve Bjorjak in Dubai has been wondering what it is in soap which actually kills all the nasties, which he's been told why he's been told to wash his hands all the time.
Okay, well, soap is a very good way of cleaning your hands because it's got oily molecules in it that will break down the membranes of microorganisms. So all microorganisms are surrounded by an oily bag which separates what's inside, the good things inside a cell, from the environment outside. And because it's oily, if you've got some detergent or soap, it can stick its wiggly chain into that oily bag, break it open, and then you bust open the bug and the stuff spills out. So that's why soap actually works and detergents work. And physically rubbing your hands together detaches microorganisms under a stream of water and removes bugs from the skin, which is also why you get cleaned up when you use some soap.
So the same reason why it's good for cleaning oil off pans and things.
Yeah, it's effectively the same thing, but you're doing it on your hands.
Brilliant.
Well, that's it for this week, and in fact this series. For the next couple of weeks we're going to be taking a look at some of the best bits of the past year, while the rest of the crew, except Petro, sorry Petro, did I forget to tell you that, will be having a nice holiday. So we'll be back at the beginning of September with a brand new series of The Naked Scientists. Now, we are very eager to hear from you in the meantime, especially if you have a science question for us, or if you just want to say hi. It's wonderful to hear from you. Just write to us, chris@thenakedscientist.com. Above all, though, thank you very much for listening to us and for sticking with this show every single week over the past year. It's been a real privilege for us to have your support, and we do really appreciate it. Thank you. Now, the other people I really have to thank are our amazing production crew. So thank you very much to Ben, Mira, Diana and Petro, because we just could not do this without you. And I want you to know that we really are grateful. Thank you very much. Thank you also to this week's guests, Rosie Hunt, Paul Harpern and Mike Hopkin. Do also, if you're listening and you're online, drop in and see our forum, nakedscientist.com/forum. That's a thriving hubbub of scientific chit-chat. And if you have a question that we can't answer for you in the meantime, then perhaps there's the place to get the answer. But above all, if you're in the Northern Hemisphere, have a great summer. If you're in the Southern Hemisphere, have a great winter. And we'll see you soon. Goodbye!